We're going to look at multiplying proper fractions. What is a proper fraction, first of all? What's a proper fraction? So if you had a number like 5 here, what kind of number could be on the top? 2/5 is a proper fraction. It's when the top number is smaller than the bottom number, right? Top number, in other words, the numerator, smaller than denominator, right? Less than. I guess we could be consistent here, bottom number. These are really technical terms, top number, bottom number. That's what it is. If you wanted to write that in that spot, you could write that in because you have to do that anyways, right? That spot. You could give another example too if you want. We're going to learn how to multiply proper fractions. Essentially what we're doing is we're doing this Explore the Math, but we're doing it together. So you can save this piece of paper.
We don't have to do this?
Well, we're going to end up doing this together more or less. We might use I might use different numbers with you, but we're going to do it right now kind of together. You're going to take the piece of paper and include it in the booklet somehow, tape it in or staple it in or whatever. If you want to multiply two proper fractions, well, at some point along the way when you learned how to multiply numbers, you thought about it as the area of a rectangle. If somebody said, what's 2 times 3? You probably made a rectangle that was 2 times 3. Or somebody said 3 times 5. You made a rectangle that's 3 times 5. Right? And you said if something is 3 this way, if it's 5 this way and 3 this way, you have 15 squares in there, right? We're going to use a rectangle to model multiplication of fractions. Okay? We're going to use a rectangle to multiply fractions here. The rectangle that we're starting with here is however big your rectangle is, we're going to say that is, this is tricky here because it probably looks something like that. It's not a square, but we're going to pretend that this is 1 and this is 1. Even though it's not a square, probably if we were doing this really perfectly, we would make it a square. We're going to pretend that's 1, I don't know what it is. It's not 1 centimeter, 1 inch, or 1 foot. It's 1 whatever, okay? So the rectangle we're calling 1. What's the area of this then? If you have something that's 1 by 1, what's its area? 1, right? 1 times 1 gives us 1. If we want to model multiplication of fractions, let's do some easy ones like 1/2 times 2, I don't know. How about, no, let's do 2/3. 1/2 times 2/3. How about that? 1/2 times 2/3. I want you to take the paper and we're going to fold the paper to represent this. One direction, if we want to model this, what we're going to do is you're going to fold the paper in half one way. So this way I want you to fold the paper along there the longer way. Fold the paper like that. Fold it over and then you're going to shade in half of it. Okay? You're going to shade it in with fold it so that the other way, so that the line is long on the paper. Yeah. Fold it along the way I drew it up here. So you make 2 halves, right? Don't do the 2/3 yet, unless you're way ahead of the game here. Some of you are ahead of the game. I want you to shade in before you fold. The other way, I want you to shade in. You could use a highlighter or you could just use a pencil. Like if you have a highlighter, you can shade in half to represent the first fraction. Or if you don't have a highlighter, you can do this, right? You can just take a pencil and you can go some lines one way like this. You don't have to do it too solid, right? Because you're going to shade the other way as well. You need 2 different types of shading. Because one direction you're going to need one type of shading. Yellow and blue highlighters would work really well because then when they're together, what color would they make? Exactly. You know your colors. Okay, I'm going to use yellow and blue here. Okay, can you look up here before we fold the other way? This is half, right? Because I have half of this whole distance we called 1, right? So if I do a distance of 1/2 here, let me take the arrow. That's 1. In fact, we might as well use the arrow tool, right? Here's 1. That arrow's 1. If I shrink this down, how much is it if I shrink this down to this distance here? Do you want to see that again? How much is this distance here? It's a half, right? So I'm going to write a half next to it. That distance is a half. So I've shaded half of it one direction. If I take my arrow the other way, which is 1, and if I shrink it down, what do I have? Well, the other direction I want to do 2/3, right? The other direction I want to do 2/3. So the reason we're doing the paper folding, or with the paper folding, we can stop in here somewhere, except you're going to try and fold your paper into 3. It's harder to fold something into 3. It's easier to fold something into 4 or 2 or 8 or something. 3 is hard to fold because you kind of have to do 2 pieces at once to try and make it. Try and fold it as close as you can into thirds this way. So try and split it into 3 and then do that. Okay? I'm going to pause this while you... So once you manage to get that folded like that, we want 2/3 here, so we're going to... Whoops. Oh, that's really good. Let's try again. We want 2/3 here, so I'm going to shrink this down to about here, right? Okay, can you... I know you're still folding there, but have a look up here. If that whole distance was 1, how long is that arrow? 2/3. Okay? I'm going to shade the other way here. I'm going to shade 2/3. Okay? This way I'm shading 2/3. Now, I'm using a blue highlighter. It changed, yes. I should have started the other way because it isn't so exciting when I start that way. But I'm using a blue highlighter the whole way there. I have an area here. The green area is an area that is this. Okay? The green area on there is 1/2 one way, 1/2 by 2/3. If you make an area that's 1/2 by 2/3, what do I have? Remember, the area of the whole black rectangle is the rectangle I started with. How big is it? 1, right? The entire rectangle was 1. How much of the rectangle is shaded now? How much of the rectangle is shaded? Like, how much is the green part here? This part is the green part. Now, I'm just talking about the overlap between the two. Because what I could have done, and maybe this would make it more obvious, is this. If I shade just the part that's 2/3 times 1/2, how much of it gets shaded? If I just shade the part that's those 2 dimensions. If I just shade that part, it's this. This is the part I'm talking about. So I did the overlap to show you, but this is just the part we're talking about, just that part. How much is that out of the whole rectangle? Hang on, let's have someone who's actually answering the question and not just saying random stuff, okay? How much? 2/6. These 2 fractions multiply out to 2/6. You got 2/6 of it. When you draw the rectangle, it's obvious what you're doing, right? It's obvious that you have 2/6 of the rectangle. Now we're going to go back to the way we were doing it before, right? Because somebody, I don't want to name names on YouTube here, but somebody was telling us the way to do this. How did you get that? What's the shortcut here? I don't want to show you the shortcut too soon because you should see how to do it from the concrete rectangle way of doing it. What's the shortcut to get to this from these two fractions? What's the shortcut? Times the numerator by the numerator, except for I just highlighted the denominator. Times the numerator by the numerator, and the denominator by the denominator. Don't lose sight of what you're doing when you're with the paper folding, with the rectangle, right? On the piece of paper you have, heavily shade the result, which is this part that's in green up here. Okay? If you have one way, you have a half, right? One way you have a half, the other way you have 2/3. The overlap is the result. Okay? The overlap is the result. Just shade the part that's the result is probably the simplest thing to do. Go 2/3 one way, 1/2 the other way, and then shade that in. Does that make sense? Does that make sense?
I get it.
You get it? I don't know if this is going to work here, but we'll try. This might not work. It won't work. If we want to do a half times 2/3 here, you stretch this out to a half, stretch that out to 2/3, you got 2/6 of the rectangle. If I was to tell you were multiplying now 2/5 times 3/7, if we were doing the paper folding, that would be kind of tricky because you have fifths and sevenths. What would our shortcut be, though? Let's think this through here. I will try to draw it up here. If we could represent the 2/5 over here, what would that be? What would we have to do here to try? And it's hard to do the paper folding, but I would have to. Should we pause? If you were doing the paper folding on this, you would have to divide it into 5 that way, and you'd have to divide it into 7 this way. It's pretty hard to do 7, so I'm just going to try my best to do 7, and I think I have not done it very well, so I'm going to do something tricky, I hope. And I'm going to do this. That's kind of tricky, eh? Okay, if you were going to represent this with fractions, you would want 2/5 this way, 2/5 this way, and 3/7 that way. How much would you have shaded? You would have shaded how many?
3 out of 7.
No, not 3 out of 7. How many would you have here? If I drew the lines here, how many would I have shaded?
5.
No, not 5. 6 out of how many?
5.
You really should focus on this because it's not a hard concept.
Out of 35.
You'd have how many? 6 out of 35. You'd have 6 out of 35 shaded. A lot of the rest of what we do is going to depend on you being able to do this, okay? I'm obviously not going to have you fold the paper for things like this. But the principle is the same. The number that you would have shaded is the top. The total number of sections would be the bottom. Okay? Are we clear on this? You should be able to represent the simpler ones with paper folding or rectangles, the rectangle model. But you should be able to get the answer with the shortcut.